There we go. That's a better one. All right. So, what are we working on tonight? We are hanging out on a Monday, and I've got to get back to studying for my PCA. I wrote up these notes last year, and I studied up for it, but I never actually went and signed up for the test. So I only have I don't know. I think until June to take it. So I need to study. I don't think the study up's going to take me too long, but I figured I'd be a little more serious about it. So if anybody wants to kind of hang out and work through it with me, and I'll go take some notes as I go on things that I need to look at and things that I need to brush up on. I think I know the one major gap that I have, and I know how I'm going to work on making that better. So if anybody wants to hang out with me and work on that, that's what we're doing. Linux, you said it's already got ads? I shouldn't have ads right as we start. That's weird. All right. So, Prolog PCA Study Guide. This was the Prometheus Certified Associate, and I have a little thing that says, "Yeah, that's weird. They're not. They're supposed to be turned off for pre-roll." So here's what the PCA is. If you guys don't know, it's this little Prometheus Certified Associate. It's a 250, but you can get it on sale. So they have it on sale pretty regularly from the Linux Foundation. Is that who does it? Yeah, Linux Foundation. And I think I got mine for like 175. It was on sale. And you can do a retake if you need. So, if I don't pass it. But really, you just need to get 45 out of 60 multiple guess correct. Multiple guess questions, right? They're not even that bad. Hey, Akshanya, how's it going? We're not working too hard. We're just kind of studying through the PCA a little bit, and I'm gonna walk through. I've got my notes out so I can pop in and do some notes on what I know that I need to study and work on as I go through it. But I figured I'd go through it with you guys if any of you guys wanted to see what I have written up about it and what I'm kind of getting ready for. I don't think this test's that bad. I just got really busy last year around June because I left a project that I was on within my company, and I started going, and some of you guys were around for it. I was working on, 3 or 4 different projects at a time, doing different security and STIG stuff. And when you do that kind of security and STIG stuff, there's quite a bit of additional, I want to say like focus. Like it's not as much just kind of, it's not as much of what you'd call like coasting. Like you're not coasting on stuff you already know how to do. You're kind of spending time with some other stuff. So, all right. Anyway, so I'm going to go through this a little bit and look at it. Here's some of the components of it. There's observability concepts, the fundamentals of how Prometheus works, which I feel really strongly in this area. I also feel pretty strongly in this area. Probably my weakest area will be PromQL, but I think that's probably true for most people. So I'll probably spend some time in there, and I'll show you guys where I plan to study on that. And then this stuff I feel pretty okay about, depending on what they ask me. But probably, these 3 areas up here are my strongest, and then this area and this area, specifically what they might ask me about alerting rules, could probably be the most problematic for me. So I'm going to go spend a little time in there. All right. Actually, I haven't played with DeepSeek at all. You've been playing with it. I thought it got people were making a big talk today about everything being what were they saying? They were saying that it was being denial of service, and I was thinking, well, maybe it's just being denial of service because it got so popular so fast and nobody was ready for it, That's also a way that things get denial of service, is just they can't handle the amount of, literally tens of millions of people that want to jump on it all the first day. So I wonder how much that was involved. But anyways, all right, so let's talk about this. If you're going to do this, there's a lot of hands-on environments. Like this test is not hands-on, but we want to know as much about it as we can. By the way, these slides are also down in the Discord as well. But our hands-on practice, Killer Coda, there's a couple of free places that you can go, and you could do a full server build. This is a course that I wrote. Or this is a link that I wrote, lab, and then a Docker build version that somebody else built. But the point is, either one of these will get you into having a Prometheus server in your hands that you are an admin of, that you can do whatever you want with. Somebody put together, Stefan Prodan put together, I don't know him, but I know his GitHub. He put together a cool little deploy, and the Home Lab deploy just sets it all up for you, so that was really cool. Actually, you said very easier to later cast it for your use case. It's more open than OpenAI. Interesting. I heard some stuff about that, how it would fix up the questions that were being asked to it. So I think that's interesting. Also, somebody told me it's on Olama, so we could technically run it in our environment if we wanted to. And another one, this is one of my favorite things, and this is probably where I'm going to spend the most time, is if you go to the Prometheus right here, and you go to their little cheat sheet, right, in the Prom Labs. One of the cool things is they'll tell you about how you can select a series of data and how you can get rate increases and use these functions that exist and all this stuff, you know, functions for 5 minutes, and they show you how to do the Prometheus queries, which is nice. But then you can also drop down into an active version of Prometheus right here. And then inside the Prometheus here, you can see, like, here's the question, here's what you said, and then here's the values that came out and showed to us as the time series database was queried. So that's something to kind of think about. Hey, I'm Octu and Robodom. How's it going, guys? We're just kind of warming up a little bit and talking about some Prometheus because I need to spend a little time with it this year. I didn't get around to it almost at all last year. I was going to go take the test in July, and I just kept kind of pushing it back with work and school and all that kind of stuff. All right. So here's how you prep the environment, right? The things that you would go do. And then observability concepts. We're going to get into metrics and log and events and tracing and spans and push and pull, service discovery, and basics of service level objectives, service level agreements, and service level indicators, right? So these are these things that we kind of need to know about in this space. All right. So a metric is of a type counter, gauge, histogram, or summary. Those are the high level types. They can be monotonic, which means they tend to only increase or decrease. So like, you know, if you collect beans, hopefully the number of beans you have is monotonic. It only goes up or only goes down. But what is not monotonic is like temperature. Temperature goes up or down throughout the day, so that's not monotonic. Monotonic means like number of events that have happened against your web server. That's always going to be increasing, right? And then there's instances, which are any endpoint you can scrape is called an instance to them. And then jobs are collections of instances. And this is one of the things I tell you guys, when we go to take a test, we have to use the exact terminology that they use. So if you're going to take your CCNA, you better know how Cisco deals with their core, their distribution, and their access. If you're going to go take a Linux Foundation test, you need to know their way of looking at things. Your waist size is non-monotonic, and expanding, and well, I guess it's better than just expanding. If it's expanding and shrinking, that's good. That's actually funny. Did this thing spell waist correctly? Nope. W-A-I-S-T. Length of my nose is monotonic. Fair enough. Fair enough. All right. So we can also click here, and we can open this up and then go spend a little time reading, right, inside of Prometheus. And I just want to make sure there's nothing here like definition-wise that I don't understand. So metrics are counters, gauges, histograms, and summaries. If I go here, it goes to a counter. Counter is a cumulative metric that represents a single monotonically increasing, right? So counters increase. Gauge is a single numerical value that can go up or down. So that's what they mean by gauge. And again, guys, if you learned it a different way in college, if you learned it a different way for engineering or systems or whatever, the point is you have to know it the way that they use it, right? So if they ask you about a counter, they're talking about this. If they talk about a gauge, it's arbitrarily going up and down. So a gauge would be like temperature. A histograms are a definition of engineering that'll always be the same, right? And a histogram is we take samples and put things typically into like a bucket. And the bucket would be you're in the first quant, the second quant, the third quant, or the fourth quant, right? And that's if you're doing different sections of blocks of things, or you're in the lowest 10%, the second 10%, and then and you can do histograms based on how the data are being collected and read, and the this deals with the amount of things that are kind of like things within the thing. So if you had 0 to 100, yeah, oh, those are quartiles. Yeah, yeah, quartiles are the quarters of things, right? Yeah. So anyways, so there's that, and then a summary is similar to a histogram. It's usually things like request durations and response sizes, so it'll give you a summary of a thing, right? And deciles are every 10%. Yep, yep. That's a good thing to know. Now they don't go that far down into that like we do in other types of engineering, but that is how histograms are typically read, and you will hear that said often. They give some different information here about like aptX scores and those kind of things that are maybe useful for you to look up, you know, and these are just kind of things that are extra, and I'm not really super worried about them in the concept of the overall PCA course, right? So that's our metrics. Go down to logs and events, and in this case, this is interesting. They're talking about their query log. We turned this on when I first wrote these about 7 months ago. I think I wrote this out. We turned on our query log and wrote all the queries into a file. So we actually know in the home lab when the systems, we actually know here in the home lab when the systems are, when the API is being hit, right? We can come over here, get out of here, SSH over to Prometheus. Prometheus. And then CD to var, var log. And in var log, we have the Prometheus section. And if we do a tail-f on query log, we can see queries that have happened, right? And these queries are probably coming, in this case, from Grafana. That's our Grafana box. But we should be able to just come over here to our normal system. And I should be able to come over here and say, what is Prometheus? 192.168. What is he in my home lab? 9090, yep. And there's the HTTP request coming from my server, or my machine here, to go hit that system. And then if I were to come in here and say, well, tell me all the systems that have an up value right now, and I see a bunch of instances that are down that I've turned off recently, but there's the query. There's the actual query hitting the API right there. I've never heard of LazyGit or LazyDocker, unfortunately. Is that something useful, Linux developer? I've never played with either of those. I've not played with it. My idea of LazyGit is let the guys run Git for the prolog. Like I set up Git yesterday, and Treasure is mostly running it. Yeah, Linux developer. I don't know if it'll share. I think Robodom has a way to allow you to share for like a minute or something. But if you put it in the Discord, we can grab it and pull it up if you want. If I just say drop it down in the Discord somewhere and let me know, and then yeah, you could share it. Yeah, just come in there and then just pop it in there somewhere, and then we'll grab it out of there. But yeah, my idea of LazyGit is let somebody else do all the Git. That's not true, but I will move away from things that bug me to things that are more interesting to me often. So here's Prometheus. We did a query against it. We see the API call happening into the server, and this is not default behavior, but it's super easy behavior to set up. So if you want your Prometheus to do that, right, all you got to do is prometheus.yaml here. All you got to do is tell it right here. Go ahead and do a query log. That's the whole value that sends out every API call in your system out to a log. And I would say in a lab environment you might not care very much, but in a enterprise, I guarantee you want to track each and every API call against that interface. You want to know who's using it and who's not, and you can then go look at usage for how utilized something is. Are we using it only 10% of what we expected to? Did we expect thousands of people per day to use it, and we only see about 3 or 4, and they're automated from some money in the company. Like that's not being like that's probably not going to get a lot of support money in the future. If, however, like when we stood up Tower, and we stood up Tower, the paid for version, my brother and I did it at an insurance company I used to work for, and we had we had proof that there were 1,500 jobs a day running from a few hundred teams in only a few months. So when they were like, "Oh, hey, if you're not gonna," when we were looking at it, and they're like, "Hey, do we want to keep funding this after the first year?" And we're like, "It's pretty embedded. Like it's very used by multiple different teams. So it ended up being pretty good, I think." Let me click on this link here real quick. risky risky click of the day. Lazy Git. That's pretty cool. Not bad. All right. Is this a terminal? Is this a terminal you run somewhere? That's pretty cool. I mean, that's pretty nice looking. Oh, it's full TUI. Okay, okay. Yeah, so it's just in your. Oh wow. I mean, that's about as lazy as I'd need it to be able to. And then here's the different sponsors for it. Elevator pitch. Yep, yep. All these have been problems, and I don't even code. I like it. Looks interesting. I don't use Git enough to probably make that useful, but that's still pretty interesting. All right, so let's get back to our little study here. I'm doing a little bit of a study session here. And I turned that on, and there's my little line that gets added to the file, and then we restart the system. Verify it's turned on, and the log format was JSON. We saw that, and you can rotate with normal Linux log rotate facility. So those are all things that that they talked about in their discussion, and things that I kind of pulled out and thought were interesting from their notes. So good. Tracing, you've got traces and spans. Traces are the individual request as it moves through all the nodes in the system, and then span is a span of time. And we can do both of those things at the command line. We can either do a trace via the metric tags that we put on it, or we can do a span based on time tags, so or timelines, because right, everything is coming out of a time series database, so that should be pretty straightforward, right? Okay. I mean, as far as like we can visually grasp what's happening with a trace and a span, right? I think we can get that. K9s is pretty good, Boris, for messing around. I like K9s where we just stand it up in like the Rocky environment, and then you just blow the machine away when you're done playing with it. So, oh no, that's K9s. That's sorry, I'm thinking K3s. There's too many Ks. There's a billion of these Ks things now. It's K3s that I'm thinking of, where we just build it real quick and then we just tear it down when we're done. I haven't played with K9s. Somebody told me what that is, but K9s like the dogs. That's funny. Actually, hold on. I don't know if everybody got this joke when I posted this earlier. Ranger had a very muddy face from walking in the door because it's raining outside, and then he got a bunch of water on his doors got water on it, and then he got his face all muddy. So that was it. And then I sent it to the wife, and then he's got mud all down the side of his head too. But it's like, I don't know, it's like that when dust gets water on it. Well, anyway, so the wife got home and I hadn't wiped it off of him. She's not even listening, but she heard me. she's sitting behind me. Hey, there's Ranger. In case you guys haven't seen Ranger standing up lately. All right. Where's that? So we can push or we can pull. Pulling is 100% the preferred way of doing everything. Yeah, Ranger's pretty good dog. Hold on, where's Ranger Cam at? We got Ranger right here. He's back on his bed. It's not as wet in Phoenix. It did rain earlier though. It rained this morning, so it actually hailed the tiniest little bit. But pushing is like, you really need to have a very specific reason to push metrics in, And you also are not supposed to think of Prometheus as just some kind of aggregated or distributed counter. It is a metrics cache. That's what it is. It's a time series database metrics cache. So then we can pull. Polling is easier to tell if instances are up or down, and there's that built-in up command where you can just check to see if things are actually up, which is awesome. And that is based on the last time that they've responded to a poll. Um, Instances are easy to add and remove. If you just stop scraping them, they go away. But if you've ever pushed a metric to a server, you will not be able to get it data back out without a manual purge. I guess I probably should just put this up by the push, but whatever. All right, service discovery. Service discovery can be file-based or HTTP-based. File-based is using Node Exporter to expose some machine on port 9100 metrics. And you can change the port number if you need. There's also a whole bunch of other default values that can be in here, or you can use specific scrape tools. Some of you guys found that out in the Linux Systems Admin course. I had you guys open up firewall ports for some of the different exporters. Like I had a Prometheus exporter, and like I think I just found one on like in the list, and I think it was what's that tool? What's that tool everybody uses for high speed networking? Oh shoot! It's an object store, and they use it instead of Gluster as a backend. Red Hat bottom. Oh gosh, I can't think of the name. It's bugging me. Can't think of the name. Anyways, you can also use HTTP base. It's what the heck's the name of that? It's a distributed object store. No. Redis isn't owned by Red Hat. Ceph. That's exactly right. It's Ceph. I was testing you guys. Yeah, it's Ceph. Redis is a cache, but it's not owned by Red Hat. Redis is owned by oh shoot, I think just Redis. Body must be valid JSON. Okay, so this is a lot of information. There's an item. If you do event based, you can do it with file. Yes, via iNotify. HTTP service discovery, no. Update frequency is instant because it lets you know. And then HTTP service discovery is whatever the refresh interval is. Format is YAML or JSON or just JSON. I would stick to just JSON typically. That's me. Transport local file or HTTP, or you can secure it if you want. If you are going to secure it, here's your methods. TLS, basic auth, which most people won't recommend in the enterprise, or authorization header, meaning you get some kind of token, which is typically like OAuth 2, right? And then this is whatever your file-based security is on this. Now I have a page for this that I want to go look at, and it's right here. This is our same thing, and they talk about comparison between the two. And then if you're going to use an HTTP service discovery, here's some things that you need to have, right? Refresh interval, default 1 minute. They love asking questions like that, little minutia about the service. Service discovery format. So you write the targets and the labels. Now this is how you actually go and scrape them. Here's your targets, and then any labels you want to put on them. Inside of your these are actually inside of your what the hell are these put? You can call these out of a file that is set up out of your Prometheus.yaml. So if I pull that up real quick, hold on. Like here at the end here, I'm using files SD configs and then anything in here .json. So like when we want to pull the information from, let's say, hostbox right here. Hostbox, this is a setup, you know, much like exactly one of these, where it's labels, job, node, team, infra, and then targets. And I just have them in a different order here than this, right? I have the labels first and the targets after because that was the model that I had used. And these get populated in my environment. Never fear the Boris here. You said, Scott, are you going to post this vid? I'm not sure exactly what you're asking, Boris. This is going on Twitch and YouTube, sure. Data Man Dark. This is also this study guide is in our Discord as well. So if you say, hey, I want to get a hold of that study guide, if you go to our Discord and you go to presentations, make sure I'm not lying. It should be down here under. There's other people's talks. Here's my Prometheus Certified Associate Prep, and I said it was as ready as it could be. So I had finished this up in August. So if you need access to it, there you go. You can download it, but it's just got it's all my notes, right? It's all the things that we're kind of studying as you walk through this. If you're going to take the cert, right? I've been getting ready to take it. I just kept getting busy with work and school last year, so I decided since I have a little break in school before I start at my new college, I decided to get on here and look at this. So this is the same thing that we just looked at, and there's the information about it. So service discovery can be file or HTTP based, and then you can control what's being read. All right. So here's the basics of service level objectives, service level agreements, and service level indicators. We talk about where you can go get a bunch of information about this. Like I'm a Linux engineer, and a bunch of you guys are Linux engineers, and I do high performance compute stuff, so I need to know this stuff. But I don't necessarily want to spin off and be a site reliability engineer or one of these DevOps guys that does a lot more of this type of stuff. So really for me, I just show you guys where some of this other stuff is, right? Like sometimes we look at it and then we go, okay, that's really cool, and I can reference this other stuff. And the other stuff that I would tell you, if this is what's interesting to you, is go over here, and then you would go to SRE.Google Books, right? And then this is where you can go and say, okay, I want to know more about SLOs. Oh, they don't have it in this one. Hold on, let's go find which book has it. One of these books has all the SLOs and SLAs and everything. So it's everything about what these things are if you want to go spend more time with it, right? So I'm constantly telling you guys that, like, if something here really interests you and you're like, hey, that's the life for me, that's what I want to go do, this is where you would go spend more time and study more about it. But for me, I just need to know that objectives are look at a service level indicator from less than or an upper bound for a lower bound, right? That's kind of my definition of it that I wrote up. Service level agreements are explicit or implicit contracts with your users. And if you're internal to a company, a lot of times your users are other engineers. So for me, as like a platform and a systems engineer, I'm almost always supporting developers. Almost 100% of the time, it's developers or researchers. And when I say researchers, researchers develop code as well, so they're developers to me, right? So I'm constantly thinking about how to make the platform more stable, more available for them, standardized across all my systems. As I deploy systems, they need to come out with the exact same code and code base, so that when they put things into their whatever their scheduling tool is, everything works for them. I want that. Those are things that I do, right? But some of you may be web managers, or you might just be data center people that want to keep your racks up. Power to your racks is the number one thing. I don't know. Being able to just ping something might be most important for you network guys, right? So there's that. And then our service level indicators are quantitative measures of some aspect of the service that's provided. So request latency, error rate. We want to standardize our indicators to frequency. And this isn't an exhaustive list, but these are kind of like the things that you might want. All right. Digging deeper. So this was all this other stuff. And again, this is in the actual, so you can, if you want all these, they're down in the Discord. What ones of these were good? I thought all these were really good. That's why I threw them in here. So, here's an actual blog from Google that had to do with the fundamentals of SLI, SLO, redefining the terminology of them. Yeah, SRE begins with the idea that availability is a prerequisite for success. And it's funny that that's the site reliability engineer's goal, because when you guys took the Linux Systems Administration course with me, anybody that stuck with me last year and did it, the number one thing that I probably said the most of every single thing, I probably said this one thing more than anything. If you are a Linux Systems Administrator, your number one metric that your operations team for your company will be judged on is uptime. 100%. your availability of the system. When I say uptime, I mean the service being available to the end user. That's going to be number one. That's going to be the number one metric that your company, like if you're determining who gets a bonuses or not, and then your system was trying to keep a 99.99% uptime, which is pretty high for like a mom and pop type, like smaller company. That's more like bigger government stuff, typically going higher than 4.9s, or big companies, big corporations. If you're trying for that and you miss that, you're probably going to miss out on part of your performance bonus. If you're, that's typically what we work for as engineers, right? Anyways, then they walk through these. So if you need to dig more into that because that's interesting to you, that's all the extra reading. All right. So now let's go into the Prometheus fundamentals. Again, this was one of the things I felt pretty strongly about. Like I think I know all these, or I know these pretty well. And then this next part, I'm also going to say I probably think I know pretty well, but we'll go over it a little bit. System architecture, configurations, those things I feel good about. Data models and understanding the limitations. Like I think I get this. But then the hard one for me will be the next one after this, which is PromQL. All right, anyways, let's keep going. So here's the system architecture. This comes directly from their page, right? So you can go click on their page and look at it. But Prometheus is sitting there. It's doing retrieval into its time series database, but it's also sharing out a web server. You can go hit that web server, which we've been doing with API calls from its front end. You can also hit it directly with, we've got service. There's a whole bunch of agents that can write and read from it, clients rather, that can read out of Prometheus if you want to. You can do it right out of a web browser like we've been doing. There's all kinds of stuff. So they even have it right here, Prometheus UI, Grafana, API clients. There's all the stuff I was just talking about, right? You can also push things out to Alert Manager, and then Alert Manager can go to PagerDuty, email, etc. One of the etc. is OpsGenie. If any of you have ever used OpsGenie, I know that because I actually just got 3 alerts last night that my OpsGenie rotation for 3 different clusters has started. So I have 3 different clusters. Well, I have like 7 clusters I'm running right now, but I have 3 clusters that I just went on call for as of last night. And you say, really? If you've been an engineer that long? Yeah, sometimes you still got to take on call when you're building stuff. This is just the nature of the beast. Nature of where you find yourself. Then your pull metrics are your job exports. Remember, Prometheus is pulling, it's scraping from these. And then there's a push gateway, which again, this is something we really want to avoid. So I'm not going to spend too much time with this. But I'll show you guys where you can go spend more time with it if you find a use case where you need to push things to a push gateway and then pull. So other things push to a push gateway, and then Prometheus scrapes from that push gateway, which, by the way, can be in the same Prometheus server. They just drew it out here because it's a separate service. And then you can do service discovery of Kubernetes or files or whatever as well. I tend to use this right here with jobs and exporters, and then I define my scrapes. But there are tools that, plug in with Kubernetes and stuff, and you can go as pods spin up, you can automatically pull stuff out. I've seen that done with FluentD, but I don't know what other tools exist out there to do that. So probably a hole in my game. Probably something I want to think about reading. Let's go see. Metrics, components, architecture. So I have a lot of the same stuff here. What does not fit? Something I often tell people too is when you're looking at Prometheus, right? And Prometheus is being, hostbox. And then I go and if I just do a curl on 127.0.0.1, whoops, on port 9090, and then I say metrics, I'll just pipe it to more. Not resolve host. Well, you guys got to stop me. What? Oh, it's 9100 on the. You guys got to really stop me. Anyways, it's 9100 here. That was my bad. Here's all of what's being presented out by this node, and every 10 seconds or so, node exporter updates these. Right? It's about every 10 seconds or so. Well, where I'm going with that is we often think about this. If your Prometheus server is down and it does not retrieve from that host box, because that was we were just reading his node exporter metrics right here, If he doesn't read that for 6 hours, does the node exporter that's updating every 20, every 10 seconds and then forgetting its metrics like a goldfish, does it know, like, you guys ever heard that, like a goldfish loses its memory every like 17 seconds or something? I know they made that a thing in a movie, like the Finding Nemo movie, but did you guys know goldfish are really like that? That's not a made up thing. Goldfish are really like that. Anyways, the reason I bring that up is because this node does not have any memory of this place. So if your Prometheus server is down for 6 hours in your environment and you have 1 or 1,000 nodes, you now have 1 or 1,000 nodes worth of nothing for 6 hours. There's no memory over here in that particular exporter that Prometheus is going to be able to go and get previous info from. That's really, really important to how you design monitoring, guys. And you say, really? Well, yeah, like, because this could be a remote link. This could be a WAN link, and maybe it's to a satellite, and the satellite's down certain times of the day. So node exporter and a pull metric like this is not it's not a use case for this. This is where, I show you guys how Telegraph works with like InfluxDB, and Telegraph can batch for hours if you want, and then send all the data when it's ready. And that is a different type of model, but it's a model that may be, depending on your use case, the correct one for what you're doing. Okay? So anyways, this is the way Prometheus works right here. The time series database writes down to the hard drive, and we'll see the hard drive stuff here in a little bit for storage. So scrape configs are defined inside of the file, and then you can override the default scrape configs. Let's go look at what the default scrape config is in mine. If I've actually, I don't think I've done. Let's look. Have I overridden my scrape config? I have not. So my global scrape config is right here, set to every 15 seconds. That's what we have set. Default is every 1 minute. I must have done that on stream one time. Like, I set that to show you guys that you can change it instead of being 1 minute. And maybe because I wanted a higher, what we call, resolution. So there we go. Yeah. All right. So, and then down here are my actual scrape configs that go, as we're defining here, to look at either my Prometheus nodes. That's the local Prometheus. This is looking on the Prometheus node for node exporter, and then these are all my scrapes for Prolog Lab, right? Which is something that I've shown you guys before. I push all that with Ansible. But Ansible's not what I'm talking about right now. We could look at that if you guys need it, but I think for the most part we don't need that. So if you need to, excuse me, go look at the different types of scrape configs that are out there. There's all kinds of them down here. All types of settings and things that you can go look at. Docker scrape config. This is Docker service discovery config. And then you can set up how it's scraping. The one that I'm using the most is, we can go up here and see a list of them here. The one I'm using the most is the file one. Where's file? The file SD config is super simple, and I can then just go and tell it read all the files, right? Where's it at? Read all the files that have this format, and then it looks like this. Right here. Here's my file config. All the files are just in this directory with .json. We can clean it up and put it down in like a lower directory. I think I was working with one of our other systems over there, but yeah. Oh, I'm not even in the... I was looking at Etsy Prometheus. Here we go. I think I also put one down here, and then I never ended up moving them down there. But you could also put them in a subdirectory and keep this directory more clean if you wanted. I didn't really care much about when I did it because I know my home lab's never going to be that big. But I could clean these out, and they'll immediately get pulled out of Prometheus pretty quickly, right? All right, so anyway, so that's how you do scrape configs, configure You can statically or dynamically assign them, like I just said. And then if you add them dynamically, I don't know how often Prometheus goes and does it, but I can tell you for sure Prometheus will go in and automatically start adding those nodes. Action, you said OAuth is something that trips you up a lot. Yeah, OAuth can be a bit of a bear. I try to stay away from that. I mean, if I have to do something up in the cloud, I'll go mess with it, but I don't spend a whole lot of time like memorizing all the OAuth stuff. All right, Prometheus has some limitations. Long-term support is on a 10-year cycle, and every 6 weeks they do a new minor release cycle. So the reason that's important to know is if a vulnerability comes up, right? Like, so if you're a somebody and you find out, from security that there's a vulnerability on certain version of Prometheus and you just haven't updated in a while, you now have to get a plan together for how you're going to protect that service. Prometheus is run a little more securely than other services. I showed this the other day, but if you do a systemctl cat Prometheus is run as a separate, so when systemd kicks this off, it's just run as the Prometheus user. So if I do a psef grep-i for Prometheus, I will see Prometheus is run from this Prometheus user. If I do a sudo-l for the user Prometheus to see what permissions they have, Prometheus is not allowed to run sudo on this box. So what does that mean? That means that if you were to compromise that process, you wouldn't really be able to do much to muck up the server. You'd be able to do plenty to take down that service and probably cause some problems, but you wouldn't have root on that box just because you compromised that service, which is the case if you were able to compromise a service that was kicked off as root. So if you guys have ever heard people talk about like, oh, we never run containers as root, and oh, we never run processes and service accounts and these kind of things as root, that's why right there. Because if that is not set to a different user, it is by default the root user that kicks it off, so it gets root permissions. And if somebody gets in there and takes over your process in some way, then now you've got a problem. So this is a certain level of risk mitigation to those kind of takeovers and that kind of stuff. Anyways, local storage limited is not clustered or replicated, so it needs to be treated like a disk. So wherever you put it, you need to treat that disk as probably your RAID 5 or out in your some kind of big storage somewhere, that kind of stuff. We put them out on direct attached storage a lot of times, and then those disks are back-ended with RAID 6 to keep them running without any kind of performance hit, that kind of stuff. Compaction happens in the background, initially 2-hour blocks, and then either 10% of data retention or 31 days, whichever is smaller. So I don't think they're going to maybe dig into that too much on the test, but I do like to know things like this. Now, if you want to know in my environment how long my Prometheus is set to store, you can actually change the value. This is the only place I know to change it right here. I've tried to change it in the file, and it doesn't take that config. Action, you said, but Docker runs as root. So your container runtime can be run as root, or you can sandbox it typically. Action, you do not have to run Docker in a root capacity that can ever be compromised on your system. No, you can run it. You can have like we use like gvisor sandboxes, and then anything that we stand up and run in there is not even on the real kernel of the box. It's on its own little like inert kernel. If anybody wants that, it looks like this. I'll send you guys a link for that. It's if you have never played with gvisor, this is a really great. Let's go find the one piece of documentation I like to show you guys. That's what it does. We do secure things with this. Where do they have it? I think it's in there. Here's their production guide. Yeah. What's the trade-off right here? This is a really good doc for people that want to go play with that kind of stuff more. And if you say, Scott, I want to build that and test it, there's a really good killer coda on it. I didn't write it. Right? You can go over to Killer Coda and see that. Say UID 0. Okay, so let's keep going with this. Data models and labels. You need to know your metric names. This is the name of what you're measuring, and you have to enable their dimensional data model to identify any given combination of labels. Right? Labels will allow any ASCII characters, numbers, and underscores. Must match that regex right there. Right? Um, Yeah, you have the two underscore. You'll see those sometimes if you're in a Prometheus system, but they are reserved. You're not allowed to use them for yourself. So you'll sometimes see them if I go here, and then right, and then, but these are already, um, they are already what are they called? They're reserved, right? You can't use those. Labels may contain any Unicode characters, and then labels with an empty label are considered equivalent to labels that do not exist. Yeah, so if you don't have a label value, they can be purged out of the system, right? Common notation, so when we read them, we'll say label name equals something, or we can use any number of like this, not this, any of those kind of things there when we do the notation for them. And then they typically, yeah, so here's an example. You would do like API HTTP requests, and you would look for method post and handler messages, and this would only return those values of API HTTP requests that match both of those metrics labels that are given. So the method can be post and the handler can be messages, right? And when you limit that, by the way, that's an and, so it has to be now this and this. So it is limiting the scope down. If it was this or this, it would expand the scope, right? But we're not doing that. So here's some best practices for it. Metric names, same kind of things I was just talking about there, right? All right. Anyways, so that I feel pretty okay about that. I'm not going to do anything crazy with their names, and I think that's fine. Exposition format. That's the way that we want to export metrics, and this is kind of what it looks like. This is what we just looked at when we looked at the host box port 9100 for a node exporter. You can curl it anytime you want. You can go look at it, right? But it is key value pair, metric name on the left, value on the right. And remember, they don't exist longer than whatever the scrape is. So if the scrape is every 15 seconds, whatever this time is, whatever these values are at that exact second, are what get collected. If they change 3 seconds later, they're not going to be read until it comes back around 15 seconds later. And if they change in that time, they're not getting collected. So that's something for you to think about. These are like text snapshots as things happen. So, all right. All right, so push gateways, again, there's very limited use cases, and always with these constraints. When monitoring multiple instances through a single push gateway, the push gateway becomes both a single point of failure and a bottleneck. So that's important to know. Some application can push metrics to the gateway, and then Prometheus will scrape it, or it can scrape it right from an application if you want it to. This is the way that you would normally want a scrape to happen. This is through a push gateway, right? It never forgets time series of data, so it will be in there forever unless you go manually purge it. So they really do recommend not doing that. All right. So when to use push gateway? Again, not very often. They really don't want you to be doing that. They say if an inbound firewall or NAT is preventing you from pulling that, I would think about my architecture if I was ever trying to do this. Yeah. Look, moving it behind the network barrier. I couldn't imagine like having NAT as a limitation within a company. Like if I was the guy running things, I would be like, guys, we need to figure something out, because that shouldn't be what stops us. So, all right. I'm not a network guy anymore, but when I was. All right, digging deeper, here's some more information on it. Again, this is up in the Discord if you guys need this. If you want to look at this from when I originally wrote it. I will be updating it kind of as we go here as I'm looking at stuff. Now, this one for sure is the part that I need to spend the most time with before I go feel good about the test. Like I could probably just walk on and take this test, but this is the part that I would spend my most time on right here for sure. So selecting data, this becomes something where you just need to practice this, I think, and you just need to kind of understand this. It's a lot like querying any type of data. All right, so how you get better at this, we have, if we have our own instance of Prometheus, like I do, I could start to add things in here. Like I can say, maybe I wanted to look at processes, right, on the processor, and then that'll start to give me a bunch of information about maybe my instances that are up or whatever. And then I can start to come in here and I can start to look by just maybe a job, and maybe I just want the job to be node, right? And then now it's going to limit it down. And then I only want the last 5 minutes maybe. And now I'll get all the values that were scraped in the last 5 minutes, right? I can start to query that down. Now, if you want to get better at this, right, then we go over here to the cheat sheet, which we had pulled up earlier. I'll link this to anybody that wants to do this. And I'll show you guys why you want to use the cheat sheet here. You can do that same thing I just did, the node CPU seconds total, and if you hit open in Prometheus, they will give you an instance of Prometheus to go play with right here. And then you say, okay, node CPU seconds total. Okay, I only want CPU 0 of each node. That's what I want. And I see that we're just looking at the same instance, but now over here I have some more information. And maybe I only want, what if I only want mode is equal to, whoops, we'll do maybe idle or system or user, right? And then we come over here and we drop this, and then we, whoops, and we do that, and it says empty query because I said, oh, if you're going to do that, it can't be exactly equal to, it's got to be like, okay, is that right? Oh, maybe it's that way. I always get that one mixed up. Ah, here we go. So now we found only the idle and only the system and only the user of that. Maybe we didn't want those other things, and we still only want that for the last 5 minutes, right? So this is where I got to get better at this. Like I got to be better at a lot of these. So this is where you come in here and you say, okay, I only want the rate of increase over the last few minutes, right? And only show me if they've been going up or down on API requests or something like that, right? So you can come in here and you can look at all of these different things. So I think this is one of the best things on the web for going and spending time with Prometheus, right? If you don't have your own Prometheus instance, but you want to get good at this stuff, there you go, right there. Look at all this stuff to go play with. So that I'm going to definitely put down in my notes. Prometheus query language. What is that? Is that PQL? Spend time with the cheat sheet. And I've seen I've had some question examples and like example questions of what might show up on there, and it looks like you just need to know how to do some of these basic queries. They'll ask you something like this and say, and if this was the data, what would it parse down to? And you just have to understand like what label it would select and maybe what time or whatever, you know, that kind of stuff. So I've seen that that's kind of what they're looking for as far as that goes from reading blogs and such about this. But yeah, you need to know, like, are we just looking right now, or are we looking in a range of time? Are we looking for a scalar to come out, or are we wanting to get a string? And typically, again, that's unused. And then do you want an equals, or what I needed was the equals tilde, which selects with a regex type string. You can put or conditions in there like I did with my straight pipes and look for this or this or this, right? Very similar to stuff you can do on any command line anywhere, right? Not equals to something or not like this. So it would get rid of, if we did not like idle, we would get all the things that were not idle on that processor, that kind of stuff. All right. Selecting data examples, so you can just read all the HTTP requests, or you can read them all with metrics. You can do the same but with 10 minutes, and then you can search for all of a job that has a certain pattern like server. I think they give some examples here that might be good. Let's go see what these look like. Let's see what this looks like. Yeah, same type of thing. And then you can do subqueries. Oh, I didn't even see that for the last 30 minutes. With it. I've never seen that before, so that's even... I'll need to add that to my notes. Oh, well, apparently that's going to move it down when I do that. But that's interesting to me right there. I did not know that behavior like that. Right? So I didn't know that you could do in the last 5-minute rate of that for the past 30 minutes with a resolution of 1 minute. Wow. Yeah, that's interesting. I had not. That is funny. Note using subqueries unnecessarily is unwise. So make sure you have a reason to parse your data down like that. I know how functions work, but I still think it could be good to understand how functions work. So you can sub by job and then go down there. So that's not too bad. You can do division and you can try to get the max. So if you're looking at it in bytes, but you want it up in gigs, there you go. Oh, sorry, bytes would go to kilobytes and then megabytes. So this would be megabytes, right? Yeah. And they're talking about MB not megabytes. So that's important to know. When they talk MI, they're talking MB. Does it even know what I'm saying? It's not whatever. I didn't think that thing would understand. But all right. So, okay, rates and derivatives. So rates are the rate of something changing. The instant rate is just the last 2 per second instant rate of like the last changes that have happened. So sometimes you want to be irate instead of just rate. I'm just kidding. No, rate will show you over a time the average rate of change, but this will show you like what just happened. So irate is sometimes something that people want to know if something's recently changed. And then deriv is designed to show change. It's not a steady bad state, but deriv will show you if you drop quickly or raise quickly into some different states. So deriv's actually kind of interesting. I wonder how much they're going to ask me about that. So, all right. So aggregation over time, we aggregate over a single instant vector, resulting in a new vector of fewer elements with aggregated values. So if we want to see the CPU for the last 5 minutes, we might say sum by CPU and get the rate of my node CPU seconds where it's not mode idle for the last 5 minutes times 100, and we would get the full CPU usage of the system, right? So I might want to go grab that. I don't think I can grab this out of here. No. I could just drop it in here, though. Hold on. Let's go grab my Prometheus. Let's see how this works in my Prometheus. So I say sum by, sum by CPU. And then I want the rate of node CPU seconds total, right? Node CPU. Oh, it didn't even want to let me complete it, huh? So I'll just sit here and type it all out then. How's that? And then mode is not equal to idle, right? And then we'll close that up and we'll say 5 minutes. And then we'll close that all out and we'll do times 100. So what is the usage of this? That box is chilling. That box is hanging out, not doing too much. Rate got an instant vector. I wonder if it's because of the... It still gave us a value, right? But that's... got an instant vector. No, you would think. Anyways, so there we go. What did I miss? Hey, thanks for the follow. Hopefully this stuff's useful to you. We are, just playing around with Prometheus and understanding this stuff better. Writing expression, invalid parameter query. 120 parse expected. Function for rate. Let's change it to irate and see what happens. Irate would be slightly different. I feel like let's take that all the way off. Let's not do the rate. Let's just do the actual. Huh. Ah, yeah. So we want an instant vector, which we did need the rate for. Okay. Well, anyway, so the point is, like, go in there and play with it. Hey, Killa, how's it going? We are just messing around with Prometheus right now. So aggregation over time. I think that makes sense. And you can aggregate things, and then you can aggregate them and then also sum them up and make a new vector that you can then call, right? Aggregation over dimensions, and we can do them by labels. So we can exclude, like, without instance. So if HTTP request total had, I think this one was like application, group, and instance. And we could say we could exclude instance, and then we would only get application and group. Or we can include application and group, and it would exclude instance. So it's like, how do you want to do it? Because these two do the same exact thing, right? But by the way, only if you understand that these were the three values. Oh, here it is right here. Yeah, they have application, instance, and group. So you can call it with all of them. You can get rid of instance, or you can only call application and group. So this is explicitly calling it, and this is implicitly denying it, right? Well, you're explicitly calling these two, which denies that by implication, right? So. All right, so labels can be used as dimensions in aggregation, which is important to know. Here's all of our binary operators, and that's the order of precedence for them, which is important to know, right? So you got your exponents, you've got your multiplication, division, modulus, and atan2. Then you have your adding and subtracting, and then you have your equality, not equal, less than or equal to, less than, greater than or equal to, and then greater than. And less, and then lastly or. So that, and I've seen that come up on a few of like the mock type questions that are out there. So knowing at least, I typically know that exponential is almost always first, and then multiplication and division, and then your adding and subtracting, and then any other ones that you want, right? These are comparison operators right here, right? And then this is and unless, and then or. That's interesting. All right. Oh, there you go over here too. All right. Histograms. You need to know what a histogram is. Yeah, good old PEMDAS. Yep. Histograms are buckets of observable things. So, if this is percentage of seniors over age 65 in each country, and then they're grouping the percentages, right? And they're grouping them and showing the number of counties. Is that country or county? Oh, county. Yeah, sorry, county. So this is histograms are buckets of observable outcomes, and that right there can be said to be a standard distribution, right? As opposed to like any of the other types of distribution. But standard distribution tends to be the one we want data expressed in if it's following what we call a normal distribution, right? There are other types of distributions, and there are other things to consider when we look at those, right? When we find our data are set up that way. All right, histograms in Prometheus. There are library supports for histograms that must be configured for it to work, so you need to be sending the data over correctly. The assumption is histogram has been generated for HTTP request duration seconds for these examples, and then you can go read if it's less than or equal to the first 30% by job, and then what they'll do is this request will show that we're under 300 milliseconds in the histogram HTTP request duration seconds, right? So if they were less than or equal to that, they'll show up. And then quantiles are much more complex, but they're common statistical characteristics. So if we want something in the top, in the 95th quantile, right? Yeah, yeah. There you go. All right, so timestamp metrics. So we can give timestamps and look at when the data was actually pulled. And they're given an epoch time, so that's going to go all the way back to 1970. Yeah, yeah, yeah. The good old bell curve. Timestamps are given by epoch, so we need to know that. This is less useful to me right here than the next one I'm going to show you, which is this. You can say time since, so time minus timestamp, and this will tell you when something last happened. So this was 8 seconds ago, and this was 10 seconds ago when this data was collected, right? So it's time as a function called minus the timestamp for whenever that was. So you can see how long ago that had happened. Killa, it rained here in Phoenix. Yeah, it was actually lightly on my side of town up in Glendale. It lightly hailed. The hail was probably a little smaller than like a BB. It was actually, the hail was coming down um, pretty straight down, but it was more like snow than it was hail. You walked outside and was soaking wet. Yeah, yeah. In the morning, it was pretty wet here. It was the rain was falling flat down, and there was no wind to it at all. I was kind of surprised. So, oh, was it raining right now, Killa? No, earlier today it rained out here on my side of town. Maybe it went down for you guys and just sat over you for all day. That's funny. Yeah, it wasn't too bad on my side of town. It only rained till about 1 up here, so 1 p.m. or so. All right, digging deeper. If you want to know more about these, this is a good write-up I found. Whoops. For what it means to be dealing with these, right? What are they in the context of monitoring? And it's like a drop or something going up, right? And then they will give you an informational. There's a context to a derivative, right? So they explain here what it kind of looks like. So it would show you what it looks like as a change, right? They talk about that here a little bit. Again, this isn't. I wouldn't say this is the focus of that test, so it's probably not something you need to spend too much time with either. So, all right. So then this last one, client libraries, instrumentation, exporters, structuring, and naming metrics. I think that this one will be less difficult maybe than some of the PromQL and that kind of stuff. But the client libraries that are out there, there's a whole bunch of official ones, and then there's unofficial third-party client libraries. You can write your own if you want. They have how to do that up on their documentation. You can always use exposition formats to expose web-based metrics. Yeah, you can. That basic little web page that we looked at earlier, you can write one of those yourself and then just scrape it. And just tell your scrape config to go pull that. That's perfectly okay. It'll work. All right. Instrumentation. Instrument everything. Every library, subsystem, and service should have at least a few metrics to give you a rough idea how it's performing. So there's online serving systems, so humans expect immediate response. There's offline type processing where nobody's really waiting for it. And then there's batch jobs where we just tell our computers to go do stuff, right? And a lot of times we'll kick these off with cron or something. But just because they're being kicked off in batch doesn't mean somebody doesn't still need them to finish at a certain time, right? So here's the things that we track and monitor. Libraries should have these type of things being monitored, right? Queries, counts, how many times they're called, errors and latency. If they're calling somewhere outside, yeah, you definitely want to track latency. Internal errors, latency, and general statistics. Those are good to get out of a library. Logging, you log every line of code. It doesn't say you have to log every line of code, but what it's saying is if you're logging something out, it should increment a counter somewhere. So then if you go look through your logs and they don't add up, there's something wrong. Something's not happening correctly or communication's not happening right. Failures should increment counters, thread pools. If you're using, threads, this gets more and more complex, especially with some of the the research science stuff where they have to send it out to multiple machines. That starts to get real complex. Caches, your queries, your hits and your misses, and overall latency. I mean, that's the hard thing about caches, right? Getting that hit miss to be that sweet spot where you're getting enough hits, where you're holding the data, but you're not holding so much data that you just tip a box over because you're just holding all the data. You have to also kind of balance that out. Collector's export gauge for how long the collection took in seconds, that kind of stuff. All right, so those are things that we can track. We don't have to memorize those. Those are just things that are probably good to understand in case they ask a question about it. There's a whole bunch of exporters out there, and I actually use some. I used this when we were doing our Linux sysadmin course. I used some of these to ask you guys some questions about a firewall being open, right? There's a Ceph exporter right there, 9128. And I think the other one I used was Zookeeper. All these different ones that are out there, and you can go look at them if you want. You don't have to memorize all these. You don't have to know the port numbers for any of these. I would probably know 9100 as Node Exporter because that's by far the most popular for us systems guys, right? And then there's a practice black box one that you can set up as well, and it'll give you stuff like this. You can run multi-target exporters, that's how you run it, and then you can curl against it to look at its metrics that's popping out. Then you can go scrape it if you want to. So they show you how to do all that. That's actually that's one I might need to spend a little time with because I definitely don't know that one. So as I'm doing this, guys, I'm talking through the things that I think I know, which is not everything. And as I'm finding things that I don't think I know very well, I'm writing them down. So I think this is an effective method for me for studying, where I just kind of like look over it and go, okay, I know most of this stuff, but I don't know this very well, so I'll go spend a little time with it. Because it does have a little bit of weight to this overall. They may ask me a question about it. And I don't like dropping points on dumb stuff. If I'm going to drop points, it should be on something I don't know. And I don't like not knowing at least all of the things that we're talking about when I go in to one of these tests. So metric names should comply with the data model for valid characters. So that was something we talked about earlier. Hetflix. Enzo, you should say that up in the Discord and see what kind of weird AI stuff the guys put together. That's funny. Hetflix. The funniest thing I've ever been asked on stream, I think it's the funniest thing, was somebody was convinced I was South African. And I'm like, I don't even know what that would sound like. Hetflix, so that's pretty good. Yeah, don't mix different types of metrics together, right? Single unit should have the same base unit across your stuff that you're tracking, and then it can have the name of the unit of measure in it, and that makes it even better, right? But there's also a bunch of base units that are already defined that they think you should use, and I would spend some time with those. Time should be in seconds, not some, quarks or something like that, and then temperature should be in Celsius. Or if you make a decision, right? Like if you're like, hey, our whole industry all we measure in our industry is the temperature of gas moving across Kansas. That's literally all we do. And the only thing that anybody's ever going to care about in your industry is Fahrenheit. Do it. Make that decision, but that's a design decision, right? It says right here, Prometheus does not have any units hard-coded. For better compatibility, base units should be used. Sure. But know that if you're the one at the end of the day that's going to look at the data, and your managers are going to look at the data, and your people out on the gas farms or wherever they move gas from, like where you're fracking and doing all that stuff, if you're out there doing that and you're only going to ever understand it as one unit, don't change it just for Prometheus. Does that make sense? Like understand that you've got some leeway here, because if this wasn't hard locked, like they said right here, it's not hard coded, meaning that they have given you the modularity and in some ways the extensibility to use it as you want. So that's an important that's valuable to know, and that's valuable to nobody's locking you in on those base units. They're just saying you should use it. I would tell you the best rule is always do the same unit because that's what you're going to understand. And nobody's ever going to mess it up. Digging deeper and reading, here's some instrumentation, and then best practices for writing those if you want to. So, again, if you guys need this, it's up in Discord. Alerting and dashboarding, yeah, again, this one's I'm a little shaky on, so I might have to grab some of this stuff out. But Prometheus Guide to Dashboarding, no more than 5 graphs on a console. That's fair. Have no more than 5 plot lines on each graph. You can get away with more if it's a stacked area graph. Okay, fair enough. And provide console template examples. Avoid more than 10 to 20 to 30 entries in a right-handed side table. Okay. If you find yourself exceeding or violating these, then you should think about how you're breaking down your systems. Okay. And then think about what the people want to see. I've told you guys, when I build dashboards, there tends to be 3 audiences. Other engineers and admins like myself, right? Like, we're engineers, we want to look at our systems. Our team that cares about, like, our NOC team, or sometimes our SOC team, depending on who it is. That's security operations or network operations, depending on what your company calls it. And those people should be looking at these types of things. Like, I want them looking at, like, overall temperature in the rack and power, and maybe even CPU and GPU draw of power. I can show them all kinds of stuff, but that's different than, like, what us engineers are looking at typically. And then the other one is I want you guys to or the last one for me is, like, management. Management tends to want to look at, like, aggregation of data over time for utilization and maybe even downtime and that kind of stuff. But they want to look at, like, longer macro view of the network, right? View of the systems, that kind of stuff. So, all right. Configuring alerting rules. So this is something they're not going to spend a whole lot of time in, but this is one that I've had to use this one quite a bit lately for some of my alerting out of these clusters I've been building. So alert, you can say instance down if the up goes to 0 for 5 minutes, and then it's going to page out and say that the instance down. So what that looks like is this. If we were looking at my Prometheus and I said up 5 minutes, right? And here's the last 5 minutes of this node. So this node has been down, 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 up. Okay, this node's up 9100, 180. I think that's I forget what 180 is in my home lab. 181, boom, here, up, up, up. But this one says if up is equal to 0 for a node for 5 minutes, kick out this severity of page, which is high enough to call somebody out, and then annotations always have a summary and a description to them, right? I feel pretty comfortable about this. You can set up a bunch of different rules in here and that kind of stuff. Time, it has to be API request latencies of greater than 1 for 10 minutes before this is going to go off, okay? So you're going to have to look at that based on your service level objectives and your service level indicators that you defined way, way earlier, right? All right. Alert manager is routing, inhibiting settings, and label matches. Yep, I'd say that those are all pretty good. AM tool can act as a linter. I need to. Let's say alert manager. I need to spend some time in alert manager. AM tool will do some verify that you have configuration at least compatible with UTF-8, so then it works when it gets fed up. And you don't want it to break your system or break your alerts because you did something incorrectly, right? Just like any linter, it just validates things and keeps you from losing your mind when you try to troubleshoot crap. All right. Alerting basics: what, when, and why, or when, what, and why. And alerting must be done in camel case. That is their requirement. Prometheus notification queue running full. They have a alerting. They've made that decision, so it's in camel case. Severity will be critical, warning, or info, and you can use only those values for that. And then you have to have a summary and a description. Alert manager config files. I'm gonna Philosophy of learning, more learning information. Okay, I think that's fine. Additional training and time. So this is back to the stuff we talked about at the beginning. Places for us to go spend more time with it. They have a PCA certification on the Prom Labs site. That's a pretty good little like warm up. Wait, do they still have it here? No, that's about it. Hold on, let's see if they have the. No, I don't see it. I thought it was there. Maybe they've changed their site up a little bit. These guys. But here's the domain competencies. You need to spend some time with this. Yeah, this is the same thing that I have in the. This is the same thing that I have in here. It has all the things you need to know. Boom. PromQL. Boom. I want to make sure. Yeah, none of these have changed. These are all the same. Okay. All right. It's not too bad. And questions, drop them in the Discord. So that was a quick little run through of all that. I didn't want to spend too much time on tonight. I know the wife's sleeping in the room here behind. She's in my office sleeping. So I'll probably drop off here. Maybe I'll go raid somebody over on the Twitch side. We don't have enough people. We won't bother raiding anybody tonight. But I appreciate you guys coming by. We will keep working on stuff like this, and we'll keep working in the home lab. We got actually quite a bit of stuff coming up in the home lab that we've been building. So, you know, if you guys have questions or that stuff, drop them down in the Discord. Robodom, there is that is a cert that you have to pay for if you want. That cert is I believe about $250, but I had gotten it on sale for like $175. I just picked it up like in June or something. So I gotta actually go take it. I haven't gotten around to taking it yet. I've been kind of lazy about it. So, yeah. All right. Well, hopefully this stuff's useful to you guys. I will talk to some of you later on this week. Take care.